So a seesaw or teeter-totter shows unbalanced forces and balanced forces. When do you think it's balanced? Alana.
Like, it's balanced, just like straight out.
Straight
like
out. Yeah. Why? Why? Just because it's just standing still?
Yeah.
Like that? When is it unbalanced? Jeremy?
When the object is like this.
So is it unbalanced when it's just like barely tipped? Or is it still balanced?
It's still unbalanced, but the side is going.
What? Speak up.
It's still unbalanced because it's not so.
That's right. So a seesaw shows balanced and unbalanced forces. And if the weight on one end of the seesaw is heavier than the other side, the heavier side goes down. So how does a seesaw work though when you see a dad and a kid going on one side? So why isn't the dad always going to be on the ground? Kyler.
I don't know. Kind of like you push down.
What does that create?
Unbalanced first.
It creates an unbalanced force, but so I think you went a little bit too far. I was saying it creates a force that goes up, right?
Yeah.
Makes sense. So you were right. So, but what happens when the kid touches the ground? Is he really going to touch the ground, or does he even need to push back down on the ground? Why? The dad weighs more, and the force doesn't really need to happen, right? So what if the dad just jumps off? What's going to happen then?
The kid's gonna go down.
The kid's going to go down. So who has been on a seesaw here? Caleb, what happened when one of your friends jumped off all of a sudden?
I slammed to the ground.
Yeah, and it wasn't that much fun just because your weight wasn't even or any of that, right? Yeah. Your butt hurts a little bit too. Yeah, that was never that much fun. So you always wanted to be have the weight pretty even. Like when your parents and you were on it, it wasn't that much fun just because your dad would have to do all the work and you couldn't really push off the ground like he could, right? Your dad or your mom. Do you need somebody?
Wait, you have Miss Ryan's class. Sorry about that.
No problem.
Actually, is my ear in here?
Yes, my ear's right here. Need my ear. So, the weights are the same, pretty much the same. They're going to be balanced. But nobody ever really wants just complete balance. They're on their seesaw to have fun. Does that make sense to everybody? So does anybody have any questions about a seesaw, teeter-totter, balanced and unbalanced forces? Yes, Jade?
How come on the bottom one, how come it shows the bag in the middle, like, that?
I think these are just illustrations. People had the same questions last class. And this one is a percentage sign, and it's just an illustration of it. Yes, it's a percentage sign.
I think the bottom one.
So now, who knows the Detroit Lions in here?
I do.
Everybody?
Yeah.
Everybody. How about who knows in the Dominican Sioux?
You
You don't know who the Detroit Lions are?
In the air.
What? Detroit Lions are the NFL football team for Detroit.
I'm not a sports fan.
Oh, okay. Christian, you know who the Dominican Sioux is?
I
Is he really big? Yeah.
Yeah.
So when we're gonna watch a movie about him, real quick. But we are going to find out how much net force he puts into somebody. So to do this, to find out how many newtons is exerted, first we need to figure out two things. What do you think we need? Jade, give out a guess.
How much force?
Force? Yeah, newtons is measuring force, so that's what we're judging. Alia?
His weight.
His weight, that's right. So first we have his weight, then we're going to divide by something. Jeremy?
Speed?
Speed. Correctly right. Correctly right. Correct. So we're going to do speed squared. Does anybody know what squared means? Lauren?
Like if it's like 6 times 6 would be 6 squared.
Yes, that's correct. So, during this movie, I want you guys just to be quiet and watch. You're gonna probably want to laugh, but just try and contain yourself. No, I did not make the video. Oh, I love that song.
Previously, we measured Indominicus.
But first, I want you to, when we find out the weight and speed, I'm going to stop and ask you guys about it, okay? You guys got to tell me. All right, I'm just going to turn it off.
His acceleration off the line and tackling force. And Sue's 3,200-pound impact was the biggest hit we ever measured. Even harder than hits by Ray Lewis and Chris Jenkins. But what we really want to know is how much force can you generate off the line? To find out, I think I drew the short straw.
Lauren, please turn it
I'm
off.
about to get in the way of a freight train. I just saw him hit the crash this time. And now I'm having serious second thoughts. I'm 5'8", 160, and Sue's 8 inches taller and almost twice as heavy.
How heavy is he?
307.
307 pounds. That's right.
My cousin weighs more.
That's a lot of weight.
Yeah, he's a pro football player too.
Fair enough.
He's 6'7".
All right. So now, keep watching.
About to launch Mr. John, 160-pound man, as high as I can, and see if I can try and throw him through the roof.
When was the last time you hit somebody 160 pounds?
I don't think I ever hit anybody 160 pounds. Looking forward to it, though.
Makes me feel good. You're looking forward to it. After getting wired up with an accelerometer to measure impact forces, it's finally time to go one-on-one against Indominicus Sue. Oh, I gotta warm up here. Alright, here we go. Oh my god, I'm about to get crushed. I don't like that twitch.
Three, two, one, go.
Sue is a high school state champ in the shot put. And he shot puts my 160-pound body nearly 10 feet at a velocity of 11 miles an hour.
How fast?
It says it right there.
So, what's 11 times 11 then?
121.
121, alright. So, we have 121 right here. So now we gotta divide it. So, 307 divided by 121. So, how many times is 121 going to 3?
0.
0. How many times is 121 going to 30?
0.
0. How many times is 121 going to 307?
Twice.
Twice. So what's 121 times 2? 2? It's just 2? 242. Okay. Total. Can't say that. So we have 242. So we have a bigger number here. So we got Stay right here. What's 107 minus 42? Or yeah. Anybody? Let's simplify it. What's 10 minus 4? 6. And what's 7 minus 2? 5. So we got 65. So we have 2 remaining 65. If you were to do it on a calculator like Mr. Zay did it earlier, it was 2.53. So that's only 2.53 newtons. All that, and Ndamukong Suh only put 2.53 newtons through John Brinkus. And he went pretty far, didn't he?
Yeah.
Isn't that crazy to think about that that's all he did? Yeah. And I think I'm pretty strong. Well, not really. Kind of do, but I kind of don't. And I can never do that. So we're going to finish watching this and we'll talk about showing that for us.
Was over 7.5 feet above the ground, courtesy of over 900 joules of energy generated by Suh.
Alright, so now we know that force equals newtons. So what do you think joules equal? Not weight, starts with W though. Caleb?
Oh.
Starts with W. Not width. We're talking about pushing through something, so it's not going to be width.
Wait.
So when I pick this up, pick like a barbell up, what is that called? That's true. Weightlifting.
Waiting.
So what am I? So
Wait.
Mr. Zay is at what right now? He's at not school, but work. So when we're talking about joules, we're always talking about work. Work. Yes.
I'd say he's at the door.
Well, no, we're talking about this is his job though. He's a parapro and this is his job, so he's at work. So we want to remember, whenever we're talking about newtons, we're talking about force, and whenever we're talking about joules, we're talking about work. Does that make sense to everybody?
Yep.
Okay, so let's finish watching this.
This amount of energy could launch 313-pound all-pro offensive guard Steve Hutchinson over 2 feet in the air. It's pretty unsettling to just feel another human being throw you like a rag doll.
I'm sorry, I don't want to be in that position either.
From the looks of things, when Suh hits the NFL, he won't have any trouble throwing his weight around or anyone else's. For Sports Science on ESPN, I'm John Brinkus.
Okay, no.
I want to see
Okay, so now we're talking. So that we just figured out what net force is. So net force is the combination of all forces acting on an object.
How old are those guys?
I don't know.
Pretty old.
Alright, so we saw that Ndamukong Suh pushed 2.53 newtons, or 2.53 newtons, which equals force, into John Brinkus. That sent him 7.6 feet in the air over a course of 10 feet. And that's amazing. Like, I don't know anybody that can do that.
Yeah, we just saw.
Fair enough. But when forces are balanced, the net force is 0. So when Mr. Zay and I, when Mr. Zay and I were pulling that tug-of-war rope, and we were balanced, our net force was 0. Sorry. What's your question? Huh?
I can prove him wrong because you don't actually know them.
Huh?
You don't actually know the guy, so it's technically you don't know so much.
Fair enough.
And that guy looks like he's married into that.
Okay, well, we're not talking about that. Jeremy?
I wonder how far the guy would go flying if the guy was like standing back and charging at him.
That's a good question. We're actually gonna, if we have time, we're gonna come see what happens. Huh? Yes, you have to raise the bottom. Sorry. So, if two children are pulling a toy and one pulls the toy away